There we go. Hello, and welcome to AWS Made Easy. We're on episode number 16. This is the Ask Us Anything podcast, and welcome everyone. Wow, it's been a busy couple of days. Raul, how are you doing? I think we're take yourself off mute and try that one again.
Just shows. So it has been a little crazy at this end. We were in Anaheim last week. I seem to have lost track of time, but got back, or the week before. Yeah. Anyway, I got back late last week from the trip to the AWS Summit, and still a little jet lagged, kind of at the fag end of my day, and as a result, you might see me yawning for a bit, but this is an exciting episode, so looking forward to it. Spend the weekend just being with family and spending some time at home. Pretty relaxed weekend. What about you?
Well, it was really good. Got back from Anaheim, trying to get back organized, back on schedule. I was going over the trip footage, and I'll show you the flight on the way in. We got a really, really neat view out of the window, so I'll put that up on the screen. So this is Seattle Port, and Hill. Depending on how nice the weather is, clouds around over the port.
I think, Stephen, your audio is getting completely suppressed by the aircraft.
Let's see. There we go. Now we're. There's the downtown. It's pretty cool. Really fun to see that view. If you're ever flying into Seattle and you're lucky to come in on a nice day, they'll circle back around and that nice downtown.
Awesome.
So that was good. Let's see, what other things did we do? We went over to the Ballard Locks this weekend with one of my sisters. And
did the salmon run or witness salmon kind of doing the crossing?
Oh, that's a perfect question.
Oh, wow.
It was really neat.
Oh, wow.
I think the last time I saw this was summer of
this year.
2018, I think. When we went to Ballard Locks and saw those, what is it called, the salmon bridge or salmon?
The salmon, the fish ladder.
The ladder. Yeah, that was what it was called.
So for those of you who don't know, salmon have to swim upstream to go back to wherever they were born. They're born in these little freshwater streams, and they swim downstream, swim around in the ocean for a couple of years, grow up, mature, and then their instincts kick in, and they go back up to the very stream where they were born. But in Seattle, there's kind of a natural barrier called the Ballard Locks, and they're about 100 years old. But in order to preserve these Ballard Locks exist because Lake Washington and Puget Sound are at different levels. And so in order to not drain Lake Washington, this has to exist. It's like an elevator for boats. But in order for the fish to continue to have their natural upstream behavior, they built this system where the fish make these jumps and these steps called a ladder. And so it's really neat to watch. You can see the salmon just going in and going upstream. So it's a pretty neat phenomena to observe every year. And I remember I remarked to my sister, I said, we've kind of come full circle because my dad always took us to the Ballard Locks. And we always complained as kids, that's so boring. We just watch the ships go up. And we were doing that to our kids.
They have to go through that rite of passage.
Yeah, but I understand what he was getting at now. It's pretty neat to watch.
I think the appreciation comes much later.
Well, yeah.
As with all things.
20 years.
True.
Right. Well, should we jump into our first segment is some very, very large instances made available to us from AWS. I'll get that queued up here and we'll jump right in.
Absolutely. Let's get started.
Okay. Here goes. Okay, the first one is Amazon EC2 high memory instances are now available in US East, South America, the Asia Pacific regions. So these are EC2 instances with 12 terabytes of memory. This is pretty incredible.
This is just insane. 12 TB of RAM to go with these instances. Can we bring up, by the way, I think the announcement's kind of gone off page or it's not come up on page.
Yep. There we go. See, we're both, there we go.
There we go. Okay, so these are some super large instances, 6 TB, 3 TB, 6 TB, 12 TB of RAM, depending on what size you pick, 56 or 112. But yeah, these SAP HANA use cases, which are what I've always driven, right from the time that the X1 32XL came out, and this is maybe 7-8 years ago. Ever since those have come, they've always been driven by SAP HANA. That seems to be the only use case. But when you really think about it, I wonder why these very large instances are not being used for databases in general, given that the more you can load up into memory, the faster those databases should really be. And yeah, these instances are
not general purpose. These are just for SAP HANA. Is that right? Because I said,
these are available as general purpose instances, and you can run SAP HANA workloads on it. The problem is that it's not available with RDS. Like, these instances are actually not available with RDS. So that just seems tricky. In fact, my struggle with that is RDS still hasn't, for the likes of Aurora, they still haven't launched the 24XL Graviton instances. Like, Graviton instances are still running, I think the 12XL, if I'm not mistaken, or 16XL. So they're not yet at 24XL. And I would love to understand the constraints of launching all of these.
Because at some level, a certain CPU can only talk to a certain amount of memory, but we don't know what that constraint is for the Graviton 3, do we? Of how large of an instance or how much memory a Graviton 3 can address.
Correct. But even the Graviton 2s are not available with the 24XL. And I would assume that given that it's a 64-bit chip, it should be able to address a 24XL. I mean, the Intel ones do. So in terms of addressable memory, I don't think that would be the constraint, but it'd be interesting to understand what they've tuned those instances to.
Yeah, so it's not an architecture issue. It is it's
Implementation,
configuration
for sure.
bundling, for whatever reason, or maybe it's just a demand. They haven't gotten the demand for it.
Yeah. By the way, just as a side note, there's an interesting conversation going on in the community about today's earlier announcement about the UAE region being opened up or being made available. And the conversation is that it's probably most services are actually not showing up over there or not yet available in the UAE region. So it feels like a very incomplete deployment of an AWS region. There's no Graviton. There are half the, CPU types, processor types are not yet available. You don't have version 2 of the API gateway. There's so many other services that are missing that it feels like a very incomplete deployment. So I think it'd be good to figure out from AWS what their strategy to rolling out a new data center looks like. Like, how do they prioritize what to put in or not to put in?
Yeah, certainly. I mean, I wonder if it's based on what hardware is available at the time, and we all know that there's global supply chain issues. So, this is what they can get, or is it this is a strategic order, or is it demand based, or are there certain hardware that can serve multiple different configurations, and this is the Nitro configuration that they chose to go with to allow these particular instances to be served? Yeah, I'm not sure.
Yeah, it's an open question that we hope someday we can get some experts from AWS to come in on the show and answer for us. But it baffles me that they've only got such a half-baked AZ going. I also wonder whether they actually did this for very specific customers who are local and local only to get them on board. Having lived in Dubai for 12 plus years and having worked very closely with the UAE AWS team, I know for a fact that they've always wanted to have the big telcos and the government institutions get onto AWS, and that was a big demand from them to, set up this region. I wonder if initially they built it just for those use cases, and will slowly over a period of time bring in those other general purpose use cases and work, and customer loads in there.
Yeah. Okay. So that brings a bigger question of, like you said, we would like to speak to someone from AWS about what's the strategy of what order do things get rolled out to a region, and how is it a general strategy, or is it driven by local demand or even demands of a particular customer, or in this case the government, UAE government within that region?
Yep.
Go ahead.
No, just coming back to this announcement. This is exciting. I don't know if, in a lot of these regions, there's that kind of demand for these instances. I think you and I were looking at some of this data earlier, and it looks like each one of these instances, what, $1 million?
Well, let's go through the calculation. So on the pricing page, the 12TB.112x large, and that's $109.20 an hour. So,
and this is 448 cores, correct?
Yes, 448 cores for 12 terabytes of RAM, EBS only. So yeah, 109.20 is your on-demand pricing. So just if you were to do this in the least efficient way possible and get on demand for a year, it would be almost $1 million.
Correct.
And then thinking about reserve instances, typically about half. So it's still $500,000 a year.
Yeah, that's a pretty pricey machine to keep running all the time.
I was trying to think about, when you go to a restaurant and then the saying is that you buy a glass of wine what the restaurant paid for the bottle. That's typically restaurant pricing. I would love to know what Amazon's pricing is for this is what we paid for
Yeah.
the server, and this is how much we rented out in terms of ratios. So I bought my first large workstation from these guys, ThinkMate, a long time ago, and I was trying to configure the most RAM that I could, and I got to.
Could you hit 12 TB? Like I
No, I
don't know
couldn't
what
get-
architecture supports 12 TB.
I'll have to look through the options more. I got it to 6 TB with 48 DIMMs, each 128 gigabytes, and so far we're at $126,000. So you could get two of these. You get three of these. But then again, you're not just paying for the hardware; you're paying for the entire experience, the entire managed, all the AWS system,
infrastructure. Yeah.
the power,
Yeah.
the reliability, the network, all that stuff.
Yeah,
Even
I mean, I would imagine that these machines burn an insane amount of power.
so this one says 1425.6 watts estimated. That's and again that's
Wait,
that's-
how many cores does this have?
This one is not as many. This is 4x 28 core Xeon.
Yeah, there's 28 cores. I mean, you're going to have 448 cores in that instance. So multiply this by 20, and that's your power consumption.
But are those actual cores as you'd see in
These are vCPUs, so half of them.
vCPU? Yeah.
Yeah, these are half of them. So if you did Graviton ones are not available. Yeah, these are just Intel. So these are Intel architecture, right? Just
Yeah.
go up.
Yeah, these are the Xeon. What do you call it? The Xeon High Large Memory.
Yeah.
Whew.
So you're still looking at 224 cores. Just I'd say still multiply by 10. That's your power consumption.
Well, so in terms of this article, in terms of this announcement, what do we think in terms of? Well, obviously, if you have a need for this, then this is this will simplify your life greatly. I mean, what were the customers who needed this before and didn't have access to it? They were either
Correct.
using it in a different data center or using on-prem hardware. So in this case, this massively adds simplification.
Yep. I would love to, if anyone out there has a real world need for these kind of instances, please reach out to us. We would love to have you on the show. We'd love for you to tell us what the experience of these instances is. And yeah, we'd love to hear your story. I am actually dying to try an experiment to see if these instances are available as spot instances. And I wonder if AWS is going to give me a call if I decide to launch 100 of these.
Well, you do
As
that
spot
in your account. that
How much is it going to cost for an hour if I ran 100 of these machines? $10 a machine.
That's a
$1,000.
$900 experiment.
It's actually just $1,000, isn't it?
No,
109.
1,000 would be 10. So
No, but it's 1/10 the price. Spot instances are at 1/10 the price.
oh, okay. Oh, okay.
No.
Because you can use it for the full hour.
Yeah. And if I used these instances, so it's $10 an hour.
No, okay. No, the 12 TB is 109.20 per hour.
Correct. But if I did spot instances,
Oh,
it would be
okay.
1/10.
I got it. Okay, sorry.
This
Yeah.
is on-demand pricing, right? But
Yeah,
if I
okay,
did spot
spot would be a
instances,
tenth. Yeah. Okay. Yeah, I'm with you.
I'd pay about $10, so that's $11. And then I run 100 of them. That's $1,100. That's not too shabby for an experiment.
The issue would be how in the world are you going to get that much data in there that quickly?
Who cares about the data? Run these machines and see what they can do.
Multiply some big matrices together, I suppose.
Yeah.
Invert a giant matrix.
I mean, you have at this point with 100 machines, what?
Oh,
There's a 12 TB, right? So 1,200 terabytes of RAM.
That's
1.2 petabytes, or roughly 1 petabyte of RAM. What can you do with 1 petabyte of RAM?
you could load the. I don't know, you could load the top 1,000 movies of Netflix, or no, you could probably load a big chunk of Netflix all at once. I don't know what you do with it.
Interesting exercise. Anyway,
All
we'll
right.
see if we can figure out if we can run these spot instances and have some fun with them. I
Well,
doubt if they'll be available as spot, but we'll try
no,
it out.
I would think that given the size of this, it would be very rare to see one pop up as spot.
True.
All right. Well, in terms of the article quality itself, it seems very clear. It would be interesting if there was a non-SAP HANA example.
I think these large everything from the X1 onwards, when as soon as you had 1 TB or more of RAM, those are all designed for HANA and HANA alone.
Yeah.
I don't know of any other use case that has come up that says I need a terabyte of RAM. Those I haven't come across.
So what do we rate this in terms of clouds? Are we saying, let's say
4 clouds?
4? All right.
Yeah, I think we're good with 4.
And we see we've got our new
Yay!
clouds that are
We
visible.
went with the orange borders.
All right. Well, let's close out this segment and go on to the next one, which is SageMaker Local. All right, this one's a bit of a funny one, I think. This is Amazon SageMaker Pipelines now supports testing of machine learning workflows in your local environment. And I'll put this article in the chat for anyone who's following along. Okay, this to me seems a bit backwards. SageMaker Pipelines is a tool that helps you build machine learning pipelines that take advantage of direct SageMaker integration. Pipelines now supports creating and testing pipelines on your local machine, each your computer, to clarify what local means. Which they should, right? You say, wait, am I reading this right? You mean local as in my local region? No, they're saying the actual physical piece of hardware on your desk.
Correct.
So with this launch, you can test SageMaker pipelines, scripts, and parameters compatibility locally before running them on SageMaker in the cloud. Yeah, so why would they do this? I mean, it seems obviously it is a cloud native setup. SageMaker is meant to be on the cloud and not locally. Yeah. This seems like, we discussed this beforehand. Is this, how do they say? Is this kind of pandering to people who have requested this? I mean, obviously this is not the direction they want to go in the long run, but why move this particular step locally?
Actually, they've done a number of services where they've started supporting local debugging and development. And I do agree with you that this feels like pandering to the developers who are reluctant to adopt all these cloud native tools in a cloud native way where you don't have to do stuff on your local machine. I think the analogy that I can give you is the cloud native IDEs, the likes of DevSpaces, Gitpod, Code Spaces, and so on. All of them have so much reluctance from developers. Somehow they feel like if they're not using their local IDE, they're not doing real world development. And that just feels messed up in terms of logic. In this particular case, all these notebooks and all these pipelines and stuff, if they're making it available locally, yeah, it feels like diluting the value. Like, why would you want to keep stuff local? It just adds more complexity. It adds more variables. It adds more, failure scenarios. Like, the setup that you have local is not the same as the setup that you have for your pipelines in the cloud.
Yeah, that's definitely. They have to do architectures, all this other stuff now.
Yeah, exactly. So I don't really understand why someone might want to do this. By the way, I still have a very skewed view of how things should be. For me, for example, even IDEs being local is virtually blasphemy at this point. Given all the tools that are out there, you shouldn't have to launch your local IDE anymore. And therefore, when someone says that you can do all these pipeline stuff locally, I cringe. I cringe that you just use a really messy machine with messed up configuration to decide how your production workloads should operate and then debug it there. Doesn't make sense.
Yeah, I agree 100%. It seems so. Why would you want to do this? It seems really backwards. I mean, maybe you'd say, okay, well, we already bought all these brand new MacBook Pros for the team, so we need to figure out how to get some mileage out of them. And this is being friendly, I suppose. It's a bit odd. And
Yeah.
I guess this is, so then going to the rating of this article, it's I would really know, they don't really say why you'd want to do this.
I am pretty sure that a lot of developers came to them and said, oh, unless we can do things locally, we are not going to use this service. And so they were kind of pandering to that. I have no doubt that was the scenario.
And I
actually think that if I were the product manager of this particular product, I wouldn't add that as a feature even if the developers were asking for it. It just adds too much complexity.
Yeah, it's just going to make problems later on.
Yeah, exactly.
You have to deal with architectures. What about when you want to train with GPUs, and then someone has an ATI, someone has a Radeon or an NVIDIA? Yeah, this is fraught with issues. So
correct.
Let's say I'm inclined to give this okay. In terms of an article, I mean, it doesn't give an example of why you'd want to do this. And I guess it's from an engineering standpoint, it's kind of cool in the sense that it's a new ability that didn't exist before. So that's, I guess, a good thing.
Yeah.
But on the overhead, I want to give this a complexity.
So I think when I give a rating for this one, it's less to do with this this article or this blog post in particular, but more to do with, I think the score that I'm about to give, or that we are about to give, is I think a reflection of the product management for this particular feature. I would actually count it as adding complexity and not something that I would have picked. Of all the things to do on SageMaker, trying to support local was not what I thought is a value add.
Yeah, no, I agree completely. I think that this exists, and now they have to support it. And the support forums are going to fill up about why this doesn't work on my particular bespoke configuration.
Correct. And there is just so many variables to take care of on the local machine. It makes no sense to me.
All right. Well, I think then I'm going to throw out the two clouds, unless you can think of another cloud to give it.
No, I think that seems fine and fair for this particular one.
Well, I guess thinking about this and thinking about the dangers of running things locally, I wanted to do a kind of a fun transition segment. There was a neat article on Hacker News recently, and it's based on it was from the author of a bit of software that I use called Lunar, and I'll put this in the chat. So Lunar is, oops, I just unplugged my keyboard. Lunar is a brightness adjustment software for Mac OS, and it handles a lot of edge cases. For example, sometimes if you have a batch of monitors, the factory will get lazy and it will put the same serial number on all of them. And this is an issue because when you have a left and a right, your Mac can't tell which one is which. Well, one interesting issue that got discussed in the comments is that there's some known issue with monitors that have very poorly shielded HDMI cables. And the issue is that when you sit on a standard office chair, there's one metal cylinder moving inside of another. And this situation can sometimes induce an electromagnetic spike. And if you have poorly shielded video cables, this can actually your cable, or you can disturb the input. and they've been able to reproduce this. So I'll add this, what it looks like. Notice this engineer here is sitting, and as he gets up, his screens turn off. We can get come back here. There you go. So they're on. They sit down and they turn off again. And so I guess the point of why we bring this up, in addition to it just being kind of fascinating from a nerdy tech perspective, is just that with local setups, there are so many edge cases that you have to deal with. And it's this person who was talking about the monitors, just kind of, it was an interesting blog post because he talked about, here's all of these different edge cases that have come up over the years of monitors with identical serial numbers, the HDMI issue, all this other stuff. And so that's why we always encourage use managed services, because then you have this great team that's taking care of all this stuff for you.
Yeah.
And we post the next day or two a clip from the talk you gave at Anaheim about tier 2 of the cost savings, which is use managed services. This is, why would you want to deal with all these little edge cases when you don't have to? And you could pay someone else at much bigger scale to deal with them.
I agree. Completely agree.
All right. Well, I posted the article in the chat. It's a fun article, so have a good read of that, and then you go on and use Aurora. All right. Well, let's take a quick break, and we come back. We'll be talking about the next article about Lex.
Public cloud costs going up and your AWS bill growing without the right cost controls? CloudFix saves you 10 to 20% on your AWS bill by focusing on AWS recommended fixes that are 100% safe with zero downtime and zero degradation in performance. The best part? With your approval, CloudFix finds and implements AWS fixes to help you run more efficiently. Visit cloudfix.com for a free savings assessment.
Whoa, we got a bunch of echo on the last one.
I think that was my fault. I unplugged what I thought was my keyboard because for some reason I misconfigured I was rearranging my office a little bit. Anyway, I unplugged my mic by mistake. Could be that. All right, Amazon Lex. Let's bring this on the screen. Here we go. Amazon Lex now supports conditional branching for simplified dialogue management. I'll put this one over here.
By the way, did we need a segment separator
yes.
on this one?
Sorry about that. We do. So take 2 and action.
Just for the audience, the reason why I call that out is because, and I'll let Stephen describe that a little bit more. We use these segment separators for a lot of automation that allows us to slice these videos up and post them as segments on various social media channels. And that automation requires the presence of these segments. So go ahead, Stephen, you can elaborate on that a little bit more.
We're going to do a special behind the scenes episode. It's now going to be 2 weeks from today, and we are very excited about that. But it shows the process that we use to automate bits of our live stream. We believe in using the stuff that we talk about, AWS services. One of them is segment detection, and so by having these introductory segments, we can get a lot of guidance, because after this video is posted in full, go back and chop it up into the bits based on what we talked about, and we use some machine learning, specifically AWS recognition, segment detection, to tell us where the different highlights are. And then, of course, we validate them by hand before we post them, but it makes it a bit faster than just going through by hand and scrolling through. So that's why we do that. And it's kind of fun. Gives us a little chance to take even that little 10-second breather to kind of clear your brain and get ready for the next. It is useful. So
completely agree.
Okay,
right. Back to Lex.
Lex is a service for building conversational interfaces into any application using voice and text. So
this is all your chatbots and IVR systems, right? So, and just for contrast, what used to happen till now is that you would create these straight flows of dialogues with the customer, but anytime you had to make different choices and pick the right choice, you would basically glue up different Lex dialogues via some custom code. And now, for the first time, you actually have conditionals that you can do on intents, or rather the slots that you get out of the intents. And you can use those conditionals to direct different dialogue flows.
Okay, so
yeah.
So on the one hand, this is going to be very helpful if you're already using Lex. It's funny that I'm surprised that this didn't exist earlier.
I think the way Lex kind of developed, there was always a Lambda handler for a bunch of stuff, and therefore, there was custom code to be written. It was just part of the way you dealt with things. And now it's neat that you have the conditional right in there within your designer, your chatbot designer, and you can use that to go down different paths.
And so this is the mechanism for Lex to get simpler, to have UIs and make this a lot easier to use for someone who wants to use Lex but maybe isn't as comfortable with Lambda.
Yeah, I'd say this. I think it doesn't make Lex simpler. I actually think that it makes Lex a little more complex, but it makes building chatbots and IVR systems way easier because you're now no longer dealing with custom code to stitch these things together. So, I'm always for figuring out simpler ways to execute the problem's solutions rather than trying to just simplify a tool. So I would absolutely give this a simplifies. Even though Lex is getting just a tiny bit more complex, I think that's totally a valid trade-off.
Yeah, in aggregate, the complexity is going down, even though in Lex in particular gets a little bit more complicated. But if you can avoid having to write a Lambda function and then you can see all the logic right in one place, because otherwise you have to open up the Lambda function and then it's always do you have to repackage the Lambda function? And if you don't remember how to do that, there's a couple of steps to zip up your Python code and upload it as a Lambda function. And if you don't remember all that, having that logic in that one place, I can't see a reason why you wouldn't want to do that. So let's see. And also there's a default condition to manage the conversation in case none of the conditions are triggered. That makes sense.
Yeah.
Okay, you reduce dependency on custom code, expedite the design and delivery of conversational interfaces. This is nice. It's available in all AWS regions at once, so you don't have to deal with rollouts 1 or 2 regions at the time.
So this is one service that's available in the UAE region that just got announced today.
Fantastic. So okay, I can't really fault this at all.
Yeah, I think this one is good. I think I would completely agree that this one is very, very good. Do we have a 4.5? Or does it go only to 5?
There you go. Nope, there's that half cloud.
Nice.
5 is reserved for, I don't know. We'll know when we get there.
Yeah, I think 5 is for ones which have a lot of examples, which have, literally, here's the follow me guide kind of setup. So I think those would fall under the examples. I think we have one service that we're going to talk about today that has that.
Well, let's transition over then to let's see, what are we doing next? We're doing the IoT Twin Maker. All right.
That's the one.
Here we go. Okay, this is AWS IoT Twin Maker launches enhancements for scaling digital twins and building data connectors. So digital twin, that's an interesting idea.
That's actually a fascinating idea. This is part of the Industrial 4.0 revolution. And just for the audience, the digital twin is nothing but a virtual representation of your physical infrastructure. So let's say you had a machine that is producing something, or you had an assembly line, or you had some kind of a workshop that's producing certain goods, or you have an entire supply chain, doesn't matter. Whatever your physical system is, you can actually start, you can use CAD modeling to create a virtual setup of that, and then start streaming all of the sensor data that you are collecting across all the sensors across the factory or the workshop or whatever you've got. Take all of that data and that material and pass it on to your virtual device. You can then train that virtual version of that device to mimic the behavior of your real physical system. Now imagine what that means for factories, or imagine what that means for plants and machineries. You can use that mechanism to predict failure of the plant or device or specific parts. You can use it as a mechanism to figure out, how key metrics would operate. You could run a bunch of different simulations. There are numerous use cases that come out of the IoT TwinMaker service. So yeah, I'm actually pretty kicked about it. To be honest, we haven't built anything with it yet, but we're just about to kickstart a project where we're going to be leveraging the IoT TwinMaker to really understand what's happening with a lot of our own internal processes.
Well, that's exciting. It'll be fun. I think we should do a special episode dedicated to that when it's all up and running. So I'll mark that down for a future one.
Correct.
It's interesting. I think about a long time ago in grad school, I had a roommate, and he was in operations management, and he was looking at. He was a classmate of mine, and he was looking at a hospital, and he was designing a new process for the elevator management of this hospital. And I can see, he had to do all these calculus-based queuing theory stuff on service time and inter-arrival processes, and being able to validate that or pair that with a simulation based on, well, at first you would do a digital twin, and then you could also do real data based on, say, the sensors at the elevator. That would be a really neat way to kind of make an empirical addition to that research.
Yeah, completely agree. And by the way, since you brought up elevators, I've been fascinated by some of these elevators that are now available, where the button you press to get to whichever floor is outside the elevator and outside of the, like, you don't make the choice of the floor you want to go to inside the elevator, you make it outside. And it tells you which one of the elevators to go to based on whatever optimization it runs. And when you really think about it, that is so simple to implement, and it is so much more effective in reducing congestion. I wonder why no one thought about it earlier.
I used to work in a building a long time ago in Brisbane, Australia, that had one of those. And it was neat because there's peak periods, right? When everyone's getting back from lunch or everything, where they can do preemptive things. Like they can have a policy of, if the elevator takes someone up to the 10th floor, just return it right back to the lobby.
Correct.
And it makes so much room for that. It's actually interesting. I remember I looked at this a long time ago. The elevators are a huge portion of a building's footprint, especially for skyscrapers. And if you can reduce the need for it while maintaining a quality of service, you get a huge amount of savings, especially over the lifetime of the building, right? How much is 100 floors of, 50 square feet over 50 years worth? It's a lot. So being able to save them. Although I think the way they used to do it, when they first came out, where the elevators were like ski lift and you just had to jump in, it was going on the way up. Oh, that would be terrifying to use.
Yeah, agreed. So TwinMaker is actually really neat. You guys should all try it out. We are going to do the same at our end with this new project that we're just kicking off. But yeah, I think the TwinMaker setup with, I think there's a service called SiteView as well, which manages temporal data. So yeah, this is an amazing tool for a lot of, understanding what's going on at the process level. So yeah, folks should use it. You can figure out whether your parts are about to die or get ruined, whether you need replacement parts, whether you're operating them at peak efficiency or not. You can gather all of that data in one place.
I'm curious to see how much work it is to get your twin to truly mimic the more complex behaviors of the actual system that you're trying to model.
Yeah, I think the amount of data that you collect becomes a big driving factor for that. The more data you have, the twin is actually able to learn from that data and create all these interesting scenarios that can then, it's fascinating.
Yeah, and it represents a bit of a shift in thinking about models, right? Because from a academic perspective, a model meant equations that govern the fundamental physics or fundamental properties of the system. But if this is based on actual data and it's saying, well, I know that for any scenario, if this goes in, this goes out, it's more like an empirical model, but it's equally useful, if not more so. All right. Well, anything else you can say about twins before we move on?
No, I think that's it on the digital twins.
Got it. All right. Well, let's do a transition. Let's take a quick break, and then when we shift back, we will be on QuickSight.
Is your AWS bill going up? CloudFix makes AWS cost savings easy and helps you with your cloud hygiene. Think of CloudFix as the Norton Utilities for AWS. AWS recommends hundreds of new fixes each year to help you run more efficiently and save money. But it's difficult to track all these recommendations and tedious to implement them. Stay on top of AWS recommended savings opportunities and continuously save 25% off your AWS bill. Visit cloudfix.com for a free savings assessment.
All right, so in our final article of today, we're looking at CloudFront supporting HTTP 3 powered by Qwik. All right, so this actually came out about 10 days, August 15th. So wow, time flies. About almost 2 weeks ago, we didn't make it in the last one, so that we'll bring this up now because it is interesting. I mean, HTTP is a pretty fundamental protocol in all of our lives, so the support for the relatively new HTTP 3, how is this going to affect our day-to-day operations?
So this one is actually really interesting. Just for some history, HTTP was the first protocol that was purely TCP. Then came HTTP2, which actually came out of a bunch of work from Google and then became a standard over a period of time, which basically brought in a bunch of other efficiencies which HTTP did not have, and it started bringing in SSL and security into the HTTP protocol. What we started realizing is that at some point in time, there was a need to get more efficient in the way the page loads were happening. And so again, at Google, they created the first version of the HTTP 3 protocol, where instead of making these really heavy duty connection, the connection protocol in TCP is pretty heavy duty. So instead of doing that, they started leveraging a UDP based connection, which became a lot more efficient. And of course, all the reliability things that came with TCP were implemented in a slightly different manner in this new protocol. But in effect, it makes the HTTP 3 is about, was it 30% faster, or somewhere between 20 and 30% more performant. I think the way it compresses stuff, the way data transfers can happen, the way site page loads come up, they are about 20 to 30% more performant than HTTP 2. And interestingly, the committee of standards is still deliberating on what HTTP 3 should have. Right now, there's an ad hoc series of documents which are being used by all the different vendors of browsers. So whether that be Microsoft or Google or Brave or name it, they've all implemented a version of HTTP 3.
I'll put
In
this
some-
in the chat.
some
Look,
form.
here's RFC 9000 supported by 9001, 9002, and 8999. So there's quick version 1 is now formalized, but yeah, there's still
Correct. So this is
part
quick
of the
version. So this is the protocol, but HTTP 3's protocol definition
Oh, I
has
see.
not
Okay.
yet been standardized. It's still in deliberation. So they expect the RFC to come out probably by the end of the year. But there are already, like most major browsers, already support HTTP 3, at least in the way it stands today. There are edge cases that are different, but we expect that IETF will make this a standard by hopefully the end of the year.
Well, it's amazing how they even quantified the amount of work they're putting into talking about it. 5 years, 26 in-person meetings, almost 1,750 issues, and thousands of emails. That's
Yeah.
pretty neat, and it's good that they can release a new standard that, like they said, is not you're not locked into the previous things. There's certain things that we do now. We do a lot more streaming these days than we used to do, and so it's good to
Yeah.
have support for things where you don't necessarily need to know if every single packet got delivered, but you want to get those packets as quickly as possible. And thus,
Yeah, I think one of the other factors is also backwards compatibility. That's kind of like a mandate for these protocols. And to make sure that the new protocols are completely backwards compatible, I think is the big debate and argument right now in the committee for this particular protocol. I think I was reading about it somewhere. So, yeah, I mean, it's no surprise because when you actually look at the RFC when it gets published, which has all the information about every discussion and everything else that happened about that particular decision. It's no surprise that it takes an entire committee to come up with these, with tons of deliberations, tons of work going behind the scenes.
Yeah. I mean, I still follow, I don't use it very much anymore, but I still follow the evolution of the C++ compiler and the C++ standard and reading how that evolves. Yeah, it's a lot of work, and it's to really fight feature creep and have that balance between backwards compatibility and looking forward. And it's a tricky thing to navigate.
Yeah.
So I'm glad I'm not doing that, but I can enjoy the benefits of it. And so for this particular article itself, with CloudFront, it supports HTTP3 powered by Qwik. So
You just have to click one checkbox, I think, if I'm not mistaken, and it turns it on for you automatically. It is completely backwards compatible, so any browser that doesn't support HTTP3 will continue to work via HTTP2, and that'll just work seamlessly. You wouldn't have to do anything else differently.
Well, looking at this, so this is great. I think this is what you're talking about in terms of article quality. So they had to enable it on your distributions. You can edit through the console, through an API action or a CloudFormation template. They give you a link to a CloudFormation template you can use. This is still going to work using previous versions. And look, it's available on all the edge locations at once. That's really good. There's no extra charge. This is great. It's hard to say, okay, it's available everywhere. Here's one CloudFormation template that you can run. Here's interesting links. I think this is doing pretty well as far as...
It's pretty good. I actually think this one is actually really good. It covered a lot of the technical details, and I was able to research, a lot of stuff around this HTTP3 implementation from AWS relatively easily. So I would give this a pretty high score. Maybe 4.5, 5, 4.5.
Ooh, all right. Well, we're setting a precedent with this 5.
I hope that we are constantly raising the bar. Was that a 4.5? Yeah, it looks like
that's a 4.5.
Yeah.
I don't know what they could have done. Should we? Oh,
sorry, go ahead.
There we go. Let's put it at 5. That's pretty good. They've got it's all regions. Doesn't cost anything else. Here's a CloudFormation template. Here's a reasonable amount of text about how it works.
Yeah, I think the blog post is pretty good. And overall, I think it also simplifies. So, yeah, I would give it the simplified stack.
Awesome. Yeah. Especially it's backwards compatible. All you have to do is run a CloudFormation template.
Right.
You don't have to, and nothing is going to break, because if the protocol doesn't support that version, it'll fall back to the previous one.
Exactly. So
So
it's relatively straightforward.
all right. Well, I think this is a good place to stop for the day. It's been a really good discussion, some interesting articles, and it's really fun just seeing how far we've gone. I remember when we were talking about that 12 terabytes of RAM. I remember being a young teenager and saving up for one stick of 32 megabyte EDO RAM. And so thinking we've gone from megabytes to gigabytes to terabytes. So I think in another decade we might be seeing this as petabytes, and this instance that we're talking about now might be the size of the Raspberry Pi 7 or whatever. Maybe the Raspberry Pi 10.
By the way, the first machine we were able to afford to buy was actually a 386, and you're talking about 32 MB of RAM. I had 4 MB of RAM, and that is a big trade-off because the 4 MB of RAM cost about half the cost of the entire machine. It was that expensive back then.
But did your machine have a turbo button?
Yes. So this was a 386 DX266, which operated at 44 megahertz.
Yep.
And it had a turbo button that would bump it up to 66 megahertz.
Mine, I remember.
Everybody we talk about megahertz and not even gigahertz.
I had a little 2-digit, 8-segment display, and ours was from 8 megahertz to 40 megahertz. And I remember this because you could play Tetris and you hit turbo and just have all the pieces just right to the bottom. It's, oh man.
Well, that's a 5x improvement in processing speed. Yeah, we used to go. So my machine used to go from 40 or 44 megahertz all the way up to 66 megahertz because it had the DX266 processor, and a 386 had that. Even though I originally started working with just the AT machines, where you had 2 floppy drives and you plug the first one in, which would boot up your half the OS, then plug in the second one, which would be the second OS, of course DOS only, and a second part of the OS, and it would boot up, and then you would put in the third floppy to do anything else that you really wanted to do.
Well, there is an old computer museum over here in Seattle. So next time you're in town, have to go over there, bring the families and let them see these machines that we grew up on, and maybe they'll appreciate what the CPU power they have today. All right,
and there's an interesting one in Palo Alto as well. If anyone wants to go check that one out,
that'd be cool. All right,
awesome.
Well, thanks again. It has been a really good segment, and we will see you all next time.
Thanks, everyone. See you all next time. Bye-bye.
Is your AWS public cloud bill growing? While most solutions focus on visibility, CloudFix saves you 10 to 20% on your AWS bill by finding and implementing AWS recommended fixes that are 100% safe. There's zero downtime and zero degradation in performance. We've helped organizations save millions of dollars across tens of thousands of AWS instances. Interested in seeing how much money you can save? Visit cloudfix.com to schedule a free assessment and see your yearly savings.